Hello and welcome to this video on section 7.3. These are the rules of replacement, part 2. So what I want to do in this video is basically just do a couple of practice exercises, and these are the ones that you're going to be doing in MindTap. We are basically adding to the rules of implication, which are the ones that were covered in section 7.1 and 7.2. So here we have the rules of implication that were covered in those sections. Please note that we are still going to use these rules here as well. So we're just adding 5 more. And so here are the rules numbers 9 through 13, which we've added. And so the first video for this section explained why those are logical rules and why they are equivalences. You should have all the rules in front of you as you work through the proofs. So they are in the reading portion of the of MindTap, in the reading section, the very first section. For all the chapters is the reading section. So they are all there. And you should be looking at them when you are working the proofs, because you're going to be applying them. Okay, so let's go ahead and start with number 6. I'm going to do number 6 and number 2 in this video. Those are part of your homework. So if you want to do that if you want to do all of them on your own and then come back and check, at least you can check 6 and 2. So this is just a kind of a warning for those of you who want to do it all on your own. Then you might want to pause the video and come back and look at it later when you've completed it. I want to start with number 6 because number 6 gives us a very good concrete example of why these are rules of replacement, or another way of saying them is substitution. And what I mean by that is that we do apply this to parts of a proposition, or we can apply them to parts of a proposition. We can actually apply them to a whole proposition, and we will do that. But the important thing to understand here is that the difference between the rules of implication, the first 8 rules, and the rules of replacement, and by the way, we have the others that you're going to learn in the next section, numbers 14 through 18. Those will be the last ones, but we're ignoring those today. The important thing to understand is that the difference between the rules of implication and the rules of replacement is that with the rules of replacement, you could replace or substitute parts of a proposition. You don't have to apply them to a whole proposition. They can apply to parts, and that's why the idea of replacing or the idea of substitution is important. Think about a car. When you have a car and say your brakes no longer work, they break down, then you could replace that part, right? And that's the idea of replacement here, is that you can do it to a part. You don't have to do it to a whole. Okay, so let's start with number 6 here. So this will also give you a good idea how this is supposed to work in MindTap. So with number 8, we have the first premises that are given to us, which is this right here, where it says premise here, premise 2 there. The conclusion, what we're trying to prove, is over here. So what we do with number 3 is we derive further premises, and we derive them deductively because this is all deduction, and we basically have to cite what rule we're using that allows us to legitimately deduce further premises. Okay, well, again, we have to look back at the rules, and with the first premise, again, because we can do this to parts, I'm going to highlight this part here. Because we could do this to parts, with the first premise, we could right away apply DeMorgan's. So notice that's because there is a tilde outside of the parentheses, and then we have a conjunction inside the parentheses, right? Well, if you look at DeMorgan's, let me enlarge this a little bit. If you look at DeMorgan, that's exactly what you have here, right? We have the tilde outside of the parentheses, and then we have a conjunction inside. So this is this variation here, and that allows us to convert it to not P or not Q, right? So we're changing it to a disjunction. So that's exactly what we could do here. So basically, we will take the tilde here and distribute it, because that is exactly what we do here. That notice that the tilde is being distributed to the P and to the Q, right? The conjunction becomes a disjunction, and then we distribute that tilde. Well, that's exactly what we're going to do here. We're going to distribute that tilde, but notice that we already have a negation inside the parentheses. So that means we have to keep that negation. We cannot change that negation. And so that becomes not E. So then we click on E here. Oh, we do need parentheses here, because we do need to remember this whole part here is an antecedent, right? And so we do need to keep that separate from the consequent, which is just a T. Okay, so we do have to insert parentheses there. Not E, and then we remember we're converting this to a disjunction, so we need the wedge, and then we distribute the tilde again to the N, right? The not N, well, actually we distribute it to the not N, so the not N stays the same, right? But we do add that other tilde. So this is what we get when we apply DeMorgan's to that first part, which is the antecedent. We're basically applying DeMorgan's to that first part, and this is what we end up getting, right? Okay, well, we still need to keep the rest of the proposition, which is the horseshoe and the T, right? That doesn't go away. We still need to keep that part. But notice what we've done here is we've successfully replaced or substituted the antecedent by the application of DeMorgan, right? So okay, now we need to cite our step here. Well, we used the DeMorgan replacement rule, which is DM, right? So we click on DM over here, and then we also did it just on step 1, right? So we have to click on step 1 there. Okay, so that's it. That's a valid use of DeMorgan. There's a legitimate use of DeMorgan. So now we go on to the next premise. Okay, so what can we get for the next premise? Okay, well, notice that that we have double negations here, right? We have not E and not N. Well, we could apply double negation to that part, so we could still work in parts here. And if we apply the double negation, we could basically get rid of all those tildes, right? So that means that we could have E. Oh, and we still need the parentheses, because this is still an antecedent. E or N, right? And notice that I don't have to do a separate double negation for E, and then do another step, and then do another separate double negation for N. I could just apply this allows me, at least this format here allows me to do it just all at once. I could just apply double negation and get rid of those tildes in the antecedent. Okay, so remember that the T stays the same. We only worked with a part there. We only worked with the antecedent, and we only applied double negation just to the antecedent, or we replaced that antecedent, or we substituted that antecedent. These are all different ways of saying what we did. It was basically the same thing. And so, okay, well, our rule here was double negation, right? So DN is over here. Click on DN. And then we applied it to premise 3, right? To our third premise. And so that's it. That's a legitimate application of double negation to step 3 there. Okay, so now the question is, where do we go next? Okay, well, notice that we're trying to prove if G then T, right? Remember, the conclusion is what we're always trying to prove. And so, well, how do we get there? Okay, notice that we have if G then N or E, and notice that we have E or N if T. Notice that this is an antecedent here, the G is an antecedent there, and the T is a consequent there. if we look at the rules, is there a rule that has something that we can work with here? And we have to go back and look at the rules of implication. Remember what I said earlier, we are using the rules of implication. Oh wow, look at the pure hypothetical syllogism right there. It looks like there's that antecedent and the consequent, and then something that connects them, right? There's the antecedent, there is a P, and then the consequent here is a Q, and then the antecedent here is a Q. But notice that we have something similar here, and then we could get, so let's go back and look at the proof. We have something similar because we have the G as that antecedent, and then the T as that consequent that we want. Remember, that's what we're trying to get. We're trying to get the if G then T. The problem is that this middle part, which corresponds to the Q here, so if we come back and look at this, the middle part that corresponds to the Q here, let me highlight the whole thing there. There has to be a middle part that connects them, as it were, so that we can get the if P then R. In this case, there has to be a middle part that connects them so that we can get the if G then T. The problem is that that middle part isn't quite the same, right? We have N or E here, and we have E or N here, right? Okay, well, is there a way that those can become the same? Is there a way that N or E or N can become the same? And the answer is yes, right? There's the rule of commutativity that allows us to switch those. Remember, that is a replacement rule, and again, we're working with a part here. So we could actually make this into N or E, and that's because of commutativity. So remember, this is a rule of replacement. We are using it for a part. In this case, we're going to apply it to line 4, to premise 4. Okay, well, we do still need the parentheses, and now we're going to have N as our letter, and then OR, and then E. We close the parentheses, and remember, we still have that T, so we have the horseshoe there, and we need the T. Okay, so now we have to cite what we did. Well, we use commutativity, right? So that's, remember, abbreviated COM, and we applied it to line 4, right? So we have to click on line 4 to apply it there, and that is a successful application of commutativity to line 4. Again, notice we only used it in a part, we substituted it, and so that should be valid. That should be fine. That should be legitimate, and it is. Okay, so all right, now we get to the final step. So again, remember that the bigger picture here is the pure hypothetical syllogism, or the HS, where we have the P, Q, and R. So let's look at what our P, Qs, and Rs are here. Okay, well, it looks like our P is our G, right? Our Q is our N or E, and notice that that's the same there, and that's the same there, right? And that's the way that it's supposed to be when we look at the hypothetical syllogism, right? The Q here is the same as the Q here, right? So that corresponds the same. Okay, well, that's going to give us the if G then T that we want, and remember, that is what we're trying to prove, is if G then T. And so our P is our G, our R is our T, and our Q is our N or E, right? Referring back to the form here. Okay, so what lines or what premises did we use to get this? Okay, well, we used line 2, right, and line 5, right, and then the rule here is the hypothetical syllogism, right? And so that is what we want to prove, and so that's it. Actually, we don't need to go to a step 7 here. We should be able to submit, and it should tell us that this is correct. We have proven what we want to prove. There it is. So let's look at the word correct here so we could feel good about ourselves. Let's see. Yep, there it is, correct. Okay, so that's it. That's with a longer proof. But again, notice what I did is I just used the rules of replacement. Okay, let me do one more, and that'll be with an easier one. So this is number 2. So again, if you want to do number 2 on your own and come back and check it later, watch the video later, that's fine. Okay, so let's make sure we're clear on what our premises are here. So our premise, there are 2 premises, J or K and L, and then not K. And then we're trying to prove J, right? We're trying to prove J. Okay, so this one should be a little bit easier than the one we just did. Okay, well, what do we notice right away? Is there anything we could do? Can we use maybe the first 8 rules, modus ponens, modus tollens? Can we use the disjunctive syllogism? It doesn't look like any of the first 8 rules will work right away, right? And these are the first 8 rules. So let's look at our new rules, the rules of replacement. And does it look like like one of them will work? Well, if we look at distribution, we notice that there is a similar pattern here. Distribution has the disjunction on the outside and the conjunction on the inside. So if you look at distribution, we have this variation right here. I think I can highlight it by itself. Let me see. Can I highlight it? Yeah, there we go. We have that variation right there in the first line, right? Imagine that the J is the P, the Q is the K is the Q, I mean, and then that the L is the R, right? We have that same exact pattern here. P as the J, K as the Q, and L as the R, right? Okay, so what does that give us? Okay, well, that allows us to literally distribute that P. This is why that's called distribution. We are, in a way, distributing one of these variables here. So we are distributing that P. And so this is what we get when we do that, right? It's right there. Remember, these are equivalences. Let me highlight that a little bit better. There we go. This is what we get when we distribute it. Okay, well, remember that our P is our J, I mean, our Q is our K. So for the first part here, we should have J. Our J is our P. I'm sorry if I misspoke earlier. Our J is our P. Our K is our Q. So if we do this correctly, then we should be able to distribute that J, which means that we do need parentheses. And then we're going to have J, and then if we go back and look at the form, we're going to have OR, so we need the disjunction, J or K, right? K will be our K is our Q, and then notice that we are going to have a conjunction. The whole thing that we are replacing it with does end up having a conjunction. And in the last video, I explained how you could memorize that. Basically, which one is inside the parentheses changes. So we are having a conjunction. The big kind of proposition here ends up being a conjunction. So we have J or K. We still have J in the first position here, in the first conjunct, and we still have the wedge, and the L is what we have over here, right? Because again, we're distributing that J in a way, and so that should look similar in form to what we have here: P or Q and P or R, J or K and J or L. Okay, so what we did there is we applied distribution, right? So our rule is distribution. We did it to line 1, and so that should be legitimate. Okay, so now the question is, what do we do? Okay, well, let's look at our conclusion. And by the way, it's always a good idea to look at the conclusion, look at what you're trying to prove. Let's look at the conclusion. We're trying to prove J. Okay, well, the first disjunct, the whole thing here is a conjunction, right? The first conjunct, I mean, does have the J or the K, right? So why don't we just pull that conjunct out and then maybe apply the disjunctive syllogism, because notice we do have a not K. At least let's just try just simplifying that conjunction. Remember, simplification is the rule, so for that we have to go back to the first rules of implication. And remember, simplification is if you have P and Q, you can get P. Well, basically what we have here is P and Q. The J or K is our P, the J or L is our Q, and that allows us to pull out the P, which would be the J or K, right? So basically that means that for this line we could have J or K, and Okay, and what we did is it's called simplification. That's how we pulled it out of there, right? And we applied simplification um, to premise 3 or line 3, right? So that's what we did. At least we could do that, right? And by the way, feel free to do whatever you can. Whatever you see that is possible to do, go ahead and do it. Okay, so that does allow us to get that J or K out of there. Now notice that we have the not K and we have the J or K. So this looks like potentially the disjunctive syllogism, right? When we look at the disjunctive syllogism, here it is. We have P or Q, not P, therefore Q. We don't quite have that because we have, if our P is our J and our Q, our K is our Q, we actually have it reversed, right? We need the K in first position so that we could apply the disjunctive syllogism. Okay, well, what do we have to do? Well, remember, with commutativity, all we have to do is switch their places, right? We could, because of the rule, the commutativity rule, we can oh, I didn't select the rule. I have to go back and select the rule, which is commutativity, COM, and I applied it to line 4. With commutativity, I can switch it, and now I can have the K or J where I want them. So now, because we have the not K here, we could apply the disjunctive syllogism, right? P or Q, not P, therefore Q. J or K, not K, therefore J, right? So basically, this allows us to just get our conclusion here, basically, what we want to prove. And all we have to do is type J, because that's what we're getting, and we're applying it to lines 2 and line 5, right? And our rule here is the disjunctive syllogism, and that gets us what we wanted to prove, right? Which is our conclusion, which was our J. Okay, so if we work, and there it is, we have the green check and the word correct. So this is how the rules apply. Keep working at it. Practice as much as possible. Remember that I will have conference calls where you could join and ask for help.